All things in the universe are created via the electron binding of atoms, and their basis is significantly affected by whether an electron is regarded as a substance or not. Modern physics does not regard an electron as a substance but as an ambiguous matter existing in the form of a probability weight, expressed using an orbital function based on the theory of atomic electron orbital functions. However, gaining a rational and clear understanding of electrons remains difficult. This principle considers an electron to be a substance and constructs noble gases, which contain the last atom of each period in the periodic table and remain in a gaseous form, as a three-dimensional structure, while considering other atoms to only exist through binding. In particular, the atomic structure of this principle is a basic element for constructing the molecular and nuclear structures. Atoms are composed of a nucleus and electrons. The atomic structure is in close relationship with the periodic table. The outer electrons of the last electrons in each period constitute the electron shell. Electron shell of noble gases is helium-2, neon and argon-8, krypton and xenon-18, radon and oganesson-32. A noble gas is in a form such that electrons are arranged in identically separated areas of the electron shell and is present by itself without combining with other atoms. Only noble gases have a fixed electronic configuration. The electrons are perfectly arranged around the atomic nucleus, and the atom circumference has a negative charge. Therefore, there is a repulsive force between noble gases, and they only exist in a gaseous form. Other atoms have an unstable electronic configuration. Consequently, they combine with other atoms to form molecular structures. Electron positions of the atoms of noble gases. Electron position of helium is symmetrically located with respect to the nucleus. These electrons dominate the surface of a hemisphere. Electron position of neon and argon are 6 sides of regular hexahedron inscribed in a sphere are expanded to the surface of the sphere to make the spherical regular hexahedron. The equator of this spherical regular hexahedron and longitudes perpendicular to the equator are drawn to divide the surface of the spherical regular hexahedron in 8 regions. The apex of a spherical regular hexahedron becomes the electron position and the electrons dominate each surface. Electron position of krypton and xenon are 3 electrons are located at the center of a geometrically identical area in 6 sides of the spherical regular hexahedron. These electrons dominate each surface. Electron position of radon and oganesson. If the surface of the sphere is divided into 8 equal parts, geometrically forming 4 equal areas, then the entire surface is divided into 32 equal areas, and for each divided area, an electron is located in the center and the corresponding electrons dominate each divided surface. The following explains the bonding and properties of the special atoms of each period, obtained from their atomic structure. Electron bonds of carbon atoms. Carbon is in period 2, group 14. It is an atom with 4 electrons in the outermost shell. When the carbon atom combines flatways in a lattice spaced out 1 by 1, it becomes graphite substance with the highest strength owing to its 4 covalent bonds. Moreover, when the carbon binding is formed in a 3-dimensional structure, it becomes a diamond, a substance with the second highest bonding strength. Electron bonds of aluminum atoms. Aluminum is in period 3, group 13. It is an atom with 3 electrons in the outermost shell. 3 electrons of an aluminum atom are located in the x, y, z directions of a spherical regular hexahedron. Aluminum is a light and strong metallic atom in period 3. Electron bonds of cobalt atoms. Cobalt is in period 4, group 9. It is an atom with 9 electrons in the outermost shell. 9 electrons of the cobalt atom are located in the x, y, z directions of a spherical regular hexahedron. Despite having a strong bonding, 3 electrons are not fixed and move around because of the effect of neighboring electrons. Thus, its strength is lower than that of chromium, which has 6 outer electrons. Cobalt is the basic atom for manufacturing magnets owing to the movement of electrons. Electron bonds of tungsten atoms. Tungsten is in period 6, group 8. It is an atom with 20 electrons in the outermost shell. 8 electrons of the tungsten atom are located at the apex of a spherical regular hexahedron, and the remaining 12 are placed in the x, y, z directions, respectively. Therefore, it is the strongest atom among metallic atoms. It is also the densest metal, with a constituent structure closely packed with electrons. The electron is a substantial material that exists in practice. Only the noble gases have a deterministic atomic structure.